is failed. I mean, in the case like while running the test in the code, and I need to revert back the code to the previous state, but I don't have the code as such. But in that case, I can go ahead with the version control system, and I can get to know like which version. I mean, the later version, and I can get to know the content of the later version, and I can rebuild the code again, and I can just push it the same code with a different version. So that's why the enterprise level, they go with the version control system. So having said that, the code part, so now the codes are developed, and once the codes are developed, the next phase, what the enterprise level do is like build. So then the build engineers will be available in the enterprise level in the company, and what they will be actually doing, they will be actually utilizing some of the major tools like Ant, Meme, and Gradle to build the source code, which is actually provided by the developer. So now the developer has provided the source code. Now the build team will build, and they will actually uh, once they build, a binary will be released, and that binary will be provided to the test team. So now the test team, what they actually do, like they will test with respect to the protocol, with respect to the latest technologies, with respect to the package managements. So with all these respects, they will be actually drafting a benchmark report. Benchmark report, having said that, what they will be doing, say for example, the particular OS is being tested in a demo switch, which the engineers will be having, which a company will be having. So in that demo switch, they'll be actually uh, generating a traffic, and they'll be allowing to that particular switch. So in that case, they will identify how much level of package to, say for example, if 200 packets is sent to the particular switch having the OS which they are actually developing. So in that case, if the OS is not crashing, then they will actually mention that this is the benchmark report for 200 packets, the OS is not crashed, it's looking fine. So say for example, if they are actually sending up 300 packets at a time, and then again they look like whether the OS is crashing or not, at that time when they actually look into the OS and it's getting crashed and it's not able to sustain such kind of traffic generation, so at that point they will benchmark a report called for so and so packets, that is for 300 packets, this OS is unsustainable. So such kind of sustainable and unsustainable reports will be taken care of by the quality testing team, and then they will be sharing the same report to the management. And now, having said all these things, now once all the testing happens, like smoke test or regression test in the enterprise level terms, after all this test, they will actually release to the portal. So once the binary has been released, what actually what the customer will be notified is the binary, the image has been released and it's available in the customer portal, so that you can download and you can deploy to the switch which you have bought. So the customer will be notified. Say for example, the example what we actually took here is Facebook. So the Facebook will be notified with an email from us, from the company, that the binary is ready, and the binary in the sense the image is ready and it's been posted in the customer portal, so that you can download and you can deploy. Now the Facebook team, they will be having the network team. Either they will be having network team to be involved in that, or else they will be asking a support from us. So there are pro professional support, as well as a support from their own team. So industry wise, what they actually do is like they will go ahead with the pro professional support, wherein the company who is actually developing the OS, they themselves will go to the premises and they will deploy, try to help. But in some companies wherein they have their own network department, they will try to download and they will try to deploy into their switches. So here, say for example, the Facebook has the same model switches. Let's take 100 in number, and they are actually connected in network. So now what the network support of the Facebook team will do is like they will be using any one of the configuration management tool or any one of the deployment tool like Ansible, SaltStack, or Chef, or Puppet, and they will analyze that how we can actually get that image which is uploaded in the customer portal and download it to their respective workspace and get it pushed to the respective switches and get it deployed at a single span of time. So once it has been deployed, the next part is operation. So now when they operate, what they will do, they will parallelly arrange a monitoring kind of system wherein they have to monitor the switches, right? So whatever may be the case, say for example, whatever may be the applications you are building and whatever may be the servers you are having in your industry, you'll be actually having some monitoring tool to have that monitor, right? So similar way, the Facebook or say Facebook as an example, what I have taken here, they will be doing, they will be deploying a monitoring tool like Nagios or Spunk or Sensu, any kind of tools they can actually use to get that monitored. So predominant in industry, solar winds is actually used for network criteria. So such kind of tools are in the market, and they are pretty much costlier. But Nagios is an open source, which actually enterprise level they use it for multiple purpose. Say for example, for monitoring the servers and for also monitoring the network devices. So now the monitoring tool has been set up in their environment. So the next part, what happens is like when the monitor at the time of monitor, when they incur with some error, say for example, some protocol testing is failed and some protocol is not working and not giving a exact behavior. So that will be recorded as a bug, and that bug will be mentioned in one of our company's portal. Say for example, Extra View is a major tool which is actually used in the enterprise level to share the customer's bug. So once the customer bug has been put in the Extra View or any kind of tool which the respective enterprises actually has, so the technical person who is actually working, or the project management who actually provided the solution to the customer, they will be actually analyzing it and they will be again planning it. So having said all these things, it's a kind of an infinite loop. That's why you are seeing this picture as an infinite loop. So again the plan happens, again based upon the requirement, again the code happens, again the build happens, again the test happens. So these are the major tools which actually gets involved in DevOps lifecycle. That is Puppet, Chef, and Ansible and SaltStack is a deployment tool wherein for test, JUnit and Selenium can be used. And for the release purpose, mostly in the enterprise level, they use Jenkins or else Bamboo. Bamboo is nothing but an Atlassian product, which is actually pretty much costlier. Wherein Jenkins, you have an open source. It's from a Cloud-B company. Okay. So having said that, let's move into the a culture part. Like the major thing what we are going to analyze is about the difference between the major enterprise tools like Ansible, Puppet, Terraform, and CloudFormation. So before getting deeper into that, have you ever asked yourself that, are you a DevOps engineer? Say for example, if any one of you are having an experience in Python, an experience in one of the DevOps tool like Ansible or Puppet, whatsoever, and an experience in Jenkins, do you claim it as yourself as a DevOps engineer? The answer is no. You can't claim it as a DevOps engineer. You can be a part of DevOps engineer, but wherein the team whom you are actually getting involved, they actually practice a DevOps. So DevOps is a practice. DevOps is a culture, wherein DevOps is not a technology. Okay. So having said all these things, so you, as of now, you would have got a good clarity like what is DevOps and what is DevOps lifecycle about, and whom you can call as a DevOps engineer. So now let's see about the introduction part of Ansible. So Ansible here, it is a configuration management tool. it is a DevOps tool, it is an IT automation tool, it is an orchestration tool, and it is a infrastructure as a code. So not many definitions can be given to Ansible. So that's why it is actually booming into the market. Okay, and it's been emerged in December 8, 2013. And the co-founder was Michael Dahan, and it is designed for multi-tier deployments. Having said, multi-tier deployments like mass deployments, say for example in your enterprise, if you want to have any kind of configuration or any kind of infrastructure to be built in bulk in number with different distros like Ubuntu, CentOS, or with different network gears. So in that case, Ansible can be the best tool which can be used to deploy in a short span of interval at larger space. So now here the Ansible was actually an open community. It was actually an open community, and at October 2015, based upon the GitHub community contributors and based upon the development of the open source Ansible, Red Hat planned to acquire Ansible in October 2015. And now the latest version of Ansible is 2.9, and the release date which they have released is November 6, 2019. So here you may ask one more question. Wherever you see, if you are getting into Google and if you search for Puppet, or if you search for OpenStack, predominantly for OpenStack, you will be coming across the release version to be quarterly. I think now the release of OpenStack is 6 months once. So at least 6 months once there will be a release. So there is a concrete deployment and concrete development of the product is going on. But here in Ansible, we can't say like the date, or we can't say the release kind of expressions. Just a moment. So we can't say the release kind of expressions as such. So it's basically depends upon the open version. So the open version, what the Ansible community work on is AWS. So the AWS project, it actually releases their product for every 2 weeks. So what the Ansible Tower, I mean, what the Ansible people, that is now they are owned by Red Hat, right? So the Red Hat people, what they will do is like they will watch out for the stable release with respect to AWS. So every 2 weeks, when the AWS releases, and if it is hassle free, if it is bug free, then Ansible, I mean the Red Hat people who is the owner of Ansible will test that, and then they will flag that as a stable version, and that version will be included in the major Ansible release. So likewise, the Ansible release actually proceeds. So now let's talk about Terraform. So Terraform is an infrastructure as a code and an orchestration tool, same as such like Ansible. But predominantly, if you get into an interview panel, if anyone is asking about Ansible, the instant answer would be configuration management tool. But here I am saying that it can act as a infrastructure as a code. How it can act? Anyways, we will be seeing the difference. Stay tuned. So now the Terraform is IAC and orchestration tool. So Terraform is a tool. It's for building and infrastructure in safely and efficient manner. And also it actually deals with cloud providers. So majorly the Terraform tool is used for cloud providers. Say for example, AWS, say for example, Google Cloud, and also some part of droplets, that is with respect to Atlassian. So major Terraform tool in the industry is used to manage the cloud providers. And the latest release of the cloud, I mean the Terraform, is 0.1224, which is released in March 19, 2020. So it's a recent release. wherein a lot of enhancements has been built up here. So you can actually spun up multiple instances, but again, there is one more block hole, like wherein if you are actually running up multiple instances, there will be an issue. I mean, there you can actually proclaim like a couple of instances. If you are actually spinning up with Terraform, only couple of instances can be actually built. If you are again trying to build up multiple instances with the same code, you can't do. So that's a major thing what we are actually looking into. So here, as I told, like Terraform is nothing but it's an infrastructure as a code and an orchestration tool, and it actually major deals with a cloud provider. So next part is Puppet. So Puppet, in most of the industries, they are actually using Puppet. Why they are actually using? Because it emerged before Ansible and before Terraform. So most of the uh, banking sectors or most of the enterprise who are actually been into existence before 2000, they were actually using Puppet, because Puppet was emerging in the later period, like 2005, and it was founded by CEO Luke Canis, and it was best configuration management tool, wherein people were admired and people were so much curious to use this, and they started using it. So the stable release was 6.15 as per 30 April 2020, and this configuration management tool was having multiple number of conflicts and multiple number of bugs in the initial period, but later they have fixed in multiple releases. But again, some of the things they were unable to actually get into the market, so that's why the other tools boomed up. So now we are actually going to see like how the other devices got boomed up, due to which, due to what, and how. So having said all these things intro, let's get into the company, so which is very much you are curious about. So this is a real-time scenario where we actually get into all these things. So now, so so here the architecture, the management, the key, and other titles which are actually seeing on the left. These are the major factors which deals with these tools: Terraform, Ansible, and Puppet. So let's begin with architecture. So the Terraform here, it actually uses master node architecture. So what do you mean by master node architecture? And what do you mean by master agent architecture? So there are two differences. Master node architecture is nothing but we don't have any kind of agent to be installed in the client nodes. Say for example, if you take Terraform or if you take Ansible, the servers, the group of servers which are actually managed by control node. The control node is nothing but the Ansible server or the Terraform host, or do not need any kind of agent installation. But wherein, if you take Puppet, you need to install agent in all the servers which you are going to manage using Puppet Master. And one more thing you have to notify, you have to note that Puppet Master server should also have a Puppet Master package as well as Puppet agent to be installed. And you may see a difference here, like a complexity would be there when there is a different in release version of Puppet agent with respect to Puppet clients as Puppet Master. So what it means, say for example, I'm having my Puppet agent 4.3 version in my clients, and in Puppet Master, if I'm having the uh, Puppet agent version to be 5.5. So in that case, will you be getting a compatibility issue or not? That may be the question. Sometimes you will be getting the conflict, but sometimes it will work. Most of the time, what you have to do is like, you have to get in touch with the Puppet support and get involved their team and get the clients upgraded to the new Puppet agent. Then only the bug fixes or the whatever the security fixes they have been, it will be enabled in both aspects, both for Puppet Master as well as both for Puppet Agent. So that is the major difference what we are actually having for Terraform, Ansible, and Puppet. And then after management, so Terraform and Ansible actually uses push configuration, wherein Puppet uses pull. So what is the actual difference between push configuration and pull configuration? Pull is nothing but the Puppet agent will poll the Puppet master for every 30 minutes. That is the default time, the default runtime interval of the Puppet agent, wherein it actually polls the Puppet master for every 30 minutes and it gets the catalog for the particular node. Catalog, having said that, how the architecture goes, let me explain that. So first of all, what happens when the Puppet is installed in your Puppet agent, I mean the Puppet client. So Puppet client is installed with Puppet agent. That Puppet agent will provide the facts to Puppet master. The Puppet master, if you are having any kind of configurations to be modified for the particular node which is actually polling, that will be represented as a catalog and it will transfer that catalog to the Puppet agent. That means Puppet client. So now when the agent runs the next time, it will ensure that that configuration is enforced here and it is modified according to that catalog. That's what in real-time world it happens. So now here it requires the combination of the Puppet agent and the Puppet master server's agent reaction and coordination. So this is a major complexity which actually enterprise actually looks upon. That's why people in the enterprise level, they go for agentless kind of architecture, wherein Ansible and Terraform comes into picture. So that is what the push and that's what the pull is all about. So it pulls the catalog from the Puppet master. Now push is as simple as such. Only the master server is Ansible control node, and you'll be having some playbooks written in that, and based upon that playbook what you have written and based upon the configuration what the clients you are having in the Puppet, I mean in the Ansible master, you will be actually pushing the particular configuration to the nodes which are actually managed using Ansible control node. So this is a push level kind of configuration which actually deals for Ansible, as well as Terraform. Terraform, the major thing the Terraform actually being used is in cloud providers like AWS. So in the major enterprise for AWS, they use Terraform. So Terraform also uses push configuration. So what they do, they actually uh, get the API of AWS and call that API with their secret key and password for accessing the API, and then they will invoke the particular configuration to be involved in the AWS part. So nothing but they actually do a push configuration. So the configuration will be done in the local host and it will be pushed to the AWS through AWS API. Simple as such. Now the keys. Here, when you take Terraform, we have to generate keys either in Terraform server or either in any of the server and use that key for ensuring that my AWS key pair is generated automatically. What I mean is like when you are actually working with AWS, you will be at one point of time, you will be actually creating key pair because AWS instance can be accessed using key pair authentication. So through private key, you will be authenticating and authenticating the instance. So what happens whenever you are creating an instance in AWS, you will be coming across a term called key pair generation. And when you click that key pair generation, automatically the key pairs will be generated, like private key and public key will be generated. Public key by default, AWS will store, and the private key will be downloaded in your local desktop. So you will be actually using some tools like putty agent, and you'll be importing that key and you'll be transforming that to a PPK file. So once it is transformed to a PPK file, nothing but a private file, you can use the public IP of the instance which is actually created in AWS and use this key to access the AWS instance. That is what actually the enterprise level we come up with. But now I don't need to log in as such. I have to log in directly from my code. So for that case, the Terraform uses the generated public key of a particular server and tries to create a key pair with that public key. So that is what here the Terraform does. Wherein the Ansible, it has its own module defined with a key pair generation. So we no need to exclusively mention any kind of public key in Ansible. But in Puppet, there is no such kind of things can be done. So this ensures that Ansible and Terraform can act as a infrastructure as a code, wherein Puppet cannot act as infrastructure as a code. It only deals with package management as well as configuration management. Now, order and semantics. Say, for example, the Terraform, whatever the things you are actually developing in Terraform, they actually represent with .tf files, and they are actually called as Terraform codes. And with respect to Ansible, you actually call as Ansible playbooks. And then with respect to Puppet, you actually called as Puppet manifest. So having said, Terraform will be having a directory structure wherein you'll be having all the files with .tf file. But here comes major conflict. If you take Ansible, the playbooks, for example, if you want to have a directory structure created for Ansible, say I'm creating a directory structure, so-called Ansible directory, and under that Ansible directory, I'm creating a playbook for installation of HTTPD, and then I'm creating a playbook for configuring my host file, and then I'm creating a playbook for configuring my network configuration. So I have 3 playbooks as such in my Ansible directory, wherein in, say, for example, let us take Terraform directory in Terraform structure, and I have some cloud instance to be created. So I have the code for cloud instance, say, for example, AWS cloud instance to be created in one of the file, .tf file. And then the another TF file I'm actually creating for Google Cloud instance. And in another instance, I'm just trying to have the same cloud instance, but with a different instance type. So here are the directory structures, how I have mentioned. So now watch carefully how it actually works. So when you take Terraform, when you run the Terraform code, you can't specify a particular Terraform file to be executed. So in Terraform folder, you have 3 files, right? So in that 3 files, you can't execute the three files separately with Terraform command, wherein when you run the command called Terraform apply, it will go to the control of each file randomly, and it will try to execute the instance. So ultimately what happens, you will be coming up with a conflict. It will throw an error, okay? But wherein in Ansible, the Ansible directory structure is having 3 playbooks, that is HTTP installation, host file configuration, and network configuration. So that 3 files, you can actually either run it separately or you can import as a role. Fine. So these are the major differences wherein the Ansible takes over Terraform into picture. But here in Puppet, you have separate environments, and you have to work on separate manifest, and the importing of profile and the importing of role is a big headache, wherein you need to ensure that the Puppet agent is properly configured and Puppet master is synced with the agent, and it is been deployed perfectly. So that is a big headache actually the Puppet has, wherein Ansible just a single playbook I need to create, and also in the Terraform part I can actually create some kind of Terraform codes. I don't need to ensure about the Puppet agent. So that's why the Puppet actually slowly getting deprecated when it is compared to Ansible or Terraform. Now, security group policies. So whenever you are creating a Terraform, whenever you are creating an AWS instance using a Terraform code, if you are mentioning a security group, that this instance should have this security group to be involved when the instance is brought up, is whether the security group will be attached to the instance which you are actually bringing up with the same code. The answer is no, you can't able to. That's actually conflict, or that's a problem of Terraform TF configuration file. But wherein in Ansible, you can write the code in the same playbook. You can write the security group, what kind of security group has to be mentioned, and for the particular instance which is actually going to brought up, and you will be surprisingly seeing that that instance will be brought up with this security group attached. So having said that, the security group is nothing but it's an inbound outbound role in the terms of Windows. Okay, so Ansible plays a major role of bringing up an instance with all the security groups and whatever may the configurations what you are actually uh, drafting in your playbook. But Puppet, as I told you, it doesn't have any kind of infrastructure as a code uh, spun up tool. So it majorly works on installing of a package and a configuration management. Say for example, if that instance which is brought up, if I need to install some kind of package at that time, if you can use actually Puppet. And one more thing, Puppet doesn't support all the kind of AWS modules and all the kind of network modules. Ansible supports most of the AWS modules, almost all of the AWS modules, and also most of the network modules. But Terraform, mostly it relies on the cloud providers and also some part of Cisco API, but wherein it doesn't work well with network peers. So now having said, let's move on to the next part. So as I told you, right, the Terraform is infrastructure as a code and an orchestration tool, but Ansible can act as both infrastructure as a code as well as an orchestration tool. But Puppet can only act as a configuration management. That is pretty much straightforward. And now the source from Terraform is like it's a kind of open source. Open source is also available, as well as an enterprise version is also available. So the support thing actually varies based upon this open source or enterprise. When you go ahead with enterprise, it is pretty much costlier than Ansible. So it is like a per instance basis, like how we actually you brought up instance and how many instance you are actually going to spun up in AWS or any kind of Google Cloud platform, and based upon that the tariff will be provided to you, and it's pretty much costlier than Ansible. Like for example, if you're taking per node, the Ansible rate would be $100 per annum, and here per node it will be and per instance it will be $150 per annum. So like such, there is a variation happens. So Ansible plays a vital role in tariff also, the cost as well. And here in Ansible, the open source is Ansible engine and the enterprise level is Ansible tower. Okay, so Ansible engine is the major a major open source which actually all of them uses. Okay, so yeah, so just a minute. So Ansible is an open source. Ansible engine is an open source, wherein predominant enterprise actually they use Ansible engine. But Ansible Tower, why they are not going? Because most of the things can be achieved using Ansible engine. And Ansible Tower, it has a good feature than Ansible engine with respect to GUI. So Ansible Tower is actually available in GUI format, where in Ansible engine, it doesn't have any kind of GUI, and most of the things has to be done using command line. So if you are having good experience in command line, then you can very well go with Ansible engine. So having said that, let's move on to Puppet. So Puppet is having open source as Puppet Server and Puppet Agent. And the enterprise level is Puppet Master. The Puppet P is nothing but Puppet Enterprise Puppet Server, and P is represents Puppet Enterprise Puppet Agent. So there also, like, you can actually deal with command line as well as GUI. So when you go with Puppet Enterprise, it actually comes up with GUI part, wherein it will be very much handy for the Windows guys who actually come from the Windows background. But wherein the people who are actually working in command line, they are pretty much used to use the open source because it is available with cost effective. So predominant in industry, they use Puppet Enterprise because to have the Puppet Enterprise support. So when you are going with Puppet Enterprise support, obviously you have to go with Puppet Enterprise. That is GUI part. Okay. So now here, one more question will arise. Like, if I'm not having any kind of experience in Linux or any kind of experience in command line, will I able to manage, or will I able to get into these kind of tools and work on? The answer is you can't. You have to know at least the base of Linux. So Linux is a booming technology, and Linux is everywhere in the universe now, wherein the people who are actually working in Windows, they are also forced to actually migrate to Linux platform. Because why I'm saying the Linux is very much important now, because all these tools, right? All these tools, what we are actually, telling about, whether Ansible or Puppet or Chef or SaltStack, regardless of Terraform, all these tools, the master node is can work only in Linux platform. They can manage Windows as a client, but they can't have Windows as a master server. So that is the best point which you can note, and you can work around. I mean, you can work on the proposal part when you are actually having some kind of crisis, like if there is any kind of tool to be used in your enterprise level, you can go with this kind of points to have the proposal done. Right. So now, what is the language used? In Terraform, HashiCorp language. It's nothing but the company which owns the Terraform. They themselves have a domain-specific language, and that language they actually use. And the file format would be .tf. And here in Ansible, it is mostly Python oriented. So Python oriented, the file compatible to the Python oriented is .yaml file. That is YAML. And then in Puppet, they actually use Ruby. So nowadays, the why the Puppet is actually getting deprecated means Ruby itself, the language itself getting deprecated, because most of the modules have been done. What kind of things can be achieved using Ruby is already done. And now the Ruby is slightly deprecating. But wherein instead of that, the advanced version, Ruby Rails, is getting emerging. But still, the engineers, the open community, they are actually working hard to ensure that all the modules which actually the competitors are having, like Ansible or Terraform, can be brought up using Puppet. So, having said all these things, if you check for how many modules are there in Puppet since 2005, is 6,482. Wherein in Ansible, it is 3080. But the emergence of Ansible was 2013. So Here in Terraform, that is like it actually deals with all the providers. So it has 15 plus providers as of now. So having said, Ansible plays a vital role, and due to which the modules are, the modules which the Ansible community prepares, they actually mostly use Python. Instead of Python, if you are using shell script, that can be also included as a Ansible module. So that is the major part where the Ansible comes into picture. So whatever the language you know, if you want to create a module in Ansible, you can do. That's simple as such. So that's why the Ansible has getting boomed up in the technology part, in the technology world. And now the next part is infrastructure code. So Terraform and Puppet, they actually focus on declarative part of approach, wherein Ansible focus on both declarative as well as procedural. So declarative, having said that, is nothing but you have to work on the instructions. You have to create some kind of instructions in the form of a .tf file. That is declarative. Wherein procedural, if I want to have any kind of installation done, or any kind of template to be transferred for the particular server to be configured, Ansible can use ad hoc command, that is external to the playbook. The command which is executed external to the playbook is called ad hoc command. So that command can be used in Ansible. That is what the procedural means. And in Puppet, again, you have to deal with manifest. So you have to write a set of instructions so that it is declarative. And one more thing, in Terraform, if you take, it actually deals with a couple of state files. One is current state, one is desired state. So whenever you run a Terraform script, that is nothing but the current state. So the Terraform script, what you are actually coding is nothing but the current state file. So when you actually run the Terraform current state file, there will be an output, and it will also create a desired state file. So if you see an output, say for example, you are creating an instance in AWS with some code, and for the first time you are running the Terraform code, and you are getting the instance generated. So from which location you are running the script, right? So at that location itself, if you if you list and see, there will be a desired state will be created. So what that desired state is about, it tells about the configuration of the particular instance which is actually brought up using that particular code. So why I'm actually enforcing that? Now, again, if I try to change some parameter in the particular code and try to run the same code again, you may be wondering that it will not get updated as per your current updation, what you've done in your code. That is the major conflict what you are what you will be facing when you are in Terraform. So what it means, it actually seeks for the data which is available in the desired state file. So in that case, how will you resolve that? So you have to ensure whether you have to ensure the desired state file is removed, and the complete thing you have to update, and then again recreate the instruction so that the Terraform state file comes, the Terraform state file or the desired file comes with the current state file data. So whenever the Terraform code is run, it seeks, if the Terraform state desired state file is there, it seeks for that input and compares it, and based upon that only it executes the particular script. For example, if the instance type mentioned in the code as t2.micro for an AWS instance.
Bala, sorry, Bala. So are you sharing some screen, like screenshot or some application? I'm not able to see that.
Naren, I'm able to see the screen, Naren.
Okay, fine. I'll proceed. Let me check. Okay, proceed. Yeah.
Okay. So what happened is like, whenever you are writing a script, say for example, you have written a script with t2.micro instance type, and for the first time you are actually executing that, and you have incurred with that exact instance according to your script, and then a Terraform decide state file is also created. So now the next step, a customer is asking that instance should have t2.nano instance type. So again, you are going and checking the same code, and if you are modifying the parameter of instance type to t2.nano, and then if you are again you are trying to rerun, whether it will get updated or not, that's the actual question. But the answer is no, it will not get updated. So always you have to get update. I mean, you have to ensure that the desired file is modified or deleted or removed or cleaned up before any kind of the modification what you are actually doing. So there are multiple things which we can actually deal with Terraform, like multiple projects can be invoked with different areas as a module, but that is a kind of advanced level. Okay, so as of now, the major thing what the Terraform actually is having, this is the actual conflict with respect to Ansible. So now when you are actually going with Ansible part, even a small change which you do in Ansible playbook, if you try to again rerun that same playbook, that gets updated in your actual instance. That's a major role of Ansible. But Puppet, as I told you again, it cannot act as an infrastructure as a code. Simple as such. So multi-version compatibility. Terraform, say now the version what I told you is like 0.12 is the latest version of Terraform, and Ansible is having latest version 2.9, and Puppet is having 6.0, right? So now, is there any possibility to have multiple Terraform version in a single server? Or is there any possibility to have multiple Ansible version in a single server, or as Puppet as so? So the possibility is with Ansible we can do. How we can do with Ansible? Since the predominant modules, I mean the modules which are in Ansible predominantly deals with Python, we can use Python virtual environment and bring in multiple versions installed in a single server, and you can switch over to the respective virtual environment to get in touch with the particular the particular Ansible version and run the playbook as such. So having said, I can share you the use case. Say for example, in your environment, you are using CentOS 5.5 and CentOS 7 version. So if you check for the Python version of CentOS 5.5, the version would be 2.4.3. But wherein, if you check for Python version in CentOS 7, it will be 2.7.5. So why I'm saying that, Ansible predominantly has a behavior of seeking the Python version as well as the SSH protocol. So the Ansible can manage the node which has current Python version, which is actually compatible with the Ansible Python version, and then the node which is going to be managed using Ansible should have SSH protocol enabled. Simple as such. So now, when the Python version, say for example 2.4.3 is there for CentOS 5.5, and for CentOS 7 is 2.7.5. So in that case, I'm having an Ansible control node as 2.9 and having the Python version as 2.7.5. Will I be able to manage the CentOS 5.5 version? Obviously, I can do for CentOS 7 because the Python version matches, but I can't unable to match or control CentOS 5.5. So in that case, you cannot go and I mean, talk to the management like, hey, I need another deployment tool to get this CentOS 5.5 accessed using my automation tool. So will the management will agree? Of course, if you are getting into the proposal mode, they will be not actually agreeing that part. So instead of that, you can create multiple Python virtual environment. Say, for example, the Python 2.4.3 can be managed using Ansible 2.3.1 version. So in that case, what you can do is like you can create a Python virtual environment and install 2.3.1 exclusive version of Ansible in the particular Python virtual environment, and you can manage the particular client which is having 2.4.3 Python version. So this is a sample example. So having said, in CentOS 7 version, say for example, the Ansible 2.9 version would be there in CentOS 7 or in Ubuntu 18. So whichever distro what you are actually working on. So in that same server, you can bring multiple Python virtual environment and you can switch to the particular Python version environment and use the particular Ansible version and manage multiple versioned Python versioned clients with the same control node. So that part we can't do in Terraform as well as Puppet. Now, that is of multi-version compatibility is about. And then world writable check. Say, for example, if a directory is having a complete permission. So in your team, you are having Ansible codes, Ansible playbooks in Ansible directory. And if you want to share it to some kind of user who will be not having access for Ansible directory, either you have to change the group permission, or either you have to change some kind of user permission, or either you have to add the particular user to the particular group or so, or either you have to tweak the file permission with world writable. But if you are actually changing the permission to world writable, say for example the directory structure, if you are actually changing the permission with all world writable, then the person or you yourself who is actually owning as an Ansible developer cannot run the playbook. Wherein Terraform or Puppet, whatever maybe the permission you are giving to the directory hierarchy, we can actually run the code. That's what here it mentions about multi-version compatibility. And then world writable check. So then the infrastructure is the code approach. So here Terraform is immutable and Ansible is mutable. So that's what I told you, right? So whenever you are actually having some Terraform code script developed, so within that, when you're running for the first time, it will create a Terraform state file wherein that is nothing but a decide state file. So it will seek for the decide state file, and based upon that, it will call up the current state file's execution instructions, and then it will spun up the instance. So that is what it is, immutable, not changeable. So it is relying on decide state. But here Ansible, it is mutable. Why it is mutable? Because it can be changed on the fly. Say for example, an instance is created and that instance should be actually brought up in some more other instance type or some more other security group. That can be modified within the same playbook and I can run the same playbook. That's what mutable. But here Puppet also does the same kind of thing. Say for example, if I need to install any kind of package, and if I need to update that same code with some kind of security groups or with some kind of firewall rules for the particular server to be configured, then I can do that. So that is called mutable. So mutable and immutable is nothing but Ansible Puppet can be adaptable for the changes. Terraform cannot be adaptable for the changes. Now, in cloud platforms, Terraform, almost all of the cloud platforms, all of the cloud providers, they actually bring the support. So Terraform supports most of the cloud providers, and also Ansible, similar to Terraform, they actually support cloud providers. Puppet, they also does, but they have some complexities in some modules. But yes, they also have provision for all the cloud providers. And encryption methodology, if you come into Terraform, can be, Terraform uses S3 bucket in AWS and RDS, Relational Database Service in AWS, to ensure that a particular data, say for example, whether it is a password or whether it's a file kind of encryption, can be put in S3 bucket or put in RDS. Wherein Ansible, by default, it is having a tool called Ansible Vault, wherein the playbook can be encrypted using Ansible Vault command. But Puppet, it actually uses Hira YAML, which actually deals with public and private key. So there is a Hira, you would have come across the people who are actually working in Puppet, they would have come across Hira kind of thing, wherein it actually uses public and private key share for ensuring the encryption is done for both password as well as for both password as well as file encryption. So now that is all about encryption methodology. And now ad hoc commands, as I told, Ansible can actually stop. Ansible uses ad hoc command. So that is the imperative part. And one more strange feature of Terraform is like when you're bringing up the instance using Terraform, say for example, AWS instance again, you can destroy the instance with all the resources, how it is actually brought up, but you can't stop or shut down using Terraform command. But Ansible, you can stop the instance, shut down the instance, and whatever the things, what the Ansible what the AWS provides for a particular instance can be done using Ansible. Puppet, as I told, it is not used for VM provisioning. So having said all these things, so these are the major part like Terraform, Ansible, and Puppet gets into. Now let us get into cloud part, wherein the cloud formation exclusively to the AWS comes into picture. So before we start, what do you mean by cloud? So you may be coming across a pictorial representation with respect to cloud representing internet. Okay, so what it means? So some kind of cloud they are actually mentioning. I'm not sure like why the internet has been put with the cloud formation. Why? So it represents multiple number of routers connected. That's why they have represented internet as a cloud. And one more thing, that is a difference between the network cloud and the network cloud representation and the actual cloud representation. So now what is cloud? Cloud deals with 5 parameters. So whenever you are asked a question in your interview, what is a cloud? Immediately you should not say it's a virtual data center, because obviously all the members will try to say the same thing. It's a virtual data center. So what is the difference between actual data center and the virtual data center? So that is where the cloud relies, right? So the actual data center and the virtual data center, what you are actually telling to the interview panelist is about 5 parameters. It relies on 5 parameters. That 5 parameters nothing but on-demand self-service, broad network access, resource pooling, rapid elasticity, and measured service. On-demand service, what it means, like say for example, I need this particular instance to be spun up at that particular time. If I call up or if I get in touch with AWS support, if I request the same, that is on-demand service. They will provide the same with any of the nearby data center. Okay, broad network access. So if you're if you're traveling in a train or traveling in a car or traveling in a bus or traveling in a flight, say for example, if you want to access your server immediately, so you can access the AWS instance from anywhere, right? So that is broad network access, wherein the physical data center, how you will be actually accessing, you have to actually get into the installation of Citrix or some kind of VPN configuration. That itself, it will be a headache, big headache, like getting into the VPN configuration itself. It will be failing obviously for a couple of times or 10 times. And then we have to get in touch with the support team. And then it's a long process, right? So that's where it deals about broad network access. What about resource pooling? Say, for example, your application is up and running with AWS instance at the backend. And that AWS instance, which is actually running at the backend, is actually configured with auto scaling. So when a particular, say, for example, IRCTC application, so whenever you are having a tuckle kind of environment, you would have come across a hang, or you would have come across an application always getting interrupted or always getting hanged out when multiple users checks in. So AWS, what happens when the application is getting down, or when the application is going to is not having enough load balance. So at that time, similar kind of instance, which is from which the application is up and running, will be brought up. Based upon the load, the auto scaling will be done in the backend of AWS. Not only AWS, in the cloud platform. So in generic manner, in cloud platform, whenever an application is hosted in the cloud platform, at the back end, the auto scaling for a particular instance, which is actually running the particular application, will be enabled. So whenever the load is more, automatically the scaling happens. That is nothing but resource pooling. When the scaling happens, right, it's like the resource kind of thing, like CPU and the memory and the hard disk will be increased, right? So that is what it deals with. So rapid elasticity, like rapid elasticity is pretty much similar to the vertical scaling and horizontal scaling. Vertical scaling in the sense the resource kind of things can be increased, either CPU or RAM or hard disk can be increased on the spot, or else horizontal scaling with respect to the instances. So rapid elasticity can be also done. Measured service. So you not need to have a particular server enabled for monitoring such kind of things. Already AWS is having CloudWatch as a monitoring tool, and even if you want to have some kind of Kibana kind of service, that can be also enabled for log viewing. So such kind of things are already being provided using cloud. So in that case, if say for example, if the cloud is coming up with a price tag of 1,000 rupees per annum, for this application to up and run. Say for example, IRCTC, if I am managing, if AWS is managing the IRCTC platform, they are coming up with a tariff like 1,000 rupees per annum you have to give for me, so that your application, I can ensure you that this application is up and running 24/7. And if you are actually managing with the separate data center, then the cost, I mean, the operational cost as well as the capital cost. So both you have to understand, and you have to build a new kind of thing wherein it is pretty much costlier than the cloud platforms provision. So that's where the cloud comes into picture. And now most of the enterprise are moving their production servers to cloud. Okay. So these are the major 5 parameters which you have to tell whenever a question is asked, like what is cloud. Next, cloud formation. Now, what do you mean by cloud formation? So cloud formation is nothing but it is a declarative way of approach for exclusive for AWS services. So it deals with most of the services. So AWS services is like more than 50 services. So almost all the services, like all the AWS services, can be managed using cloud formation. It is a kind of infrastructure as a code wherein you can actually create a stack kind of thing. Stack is nothing but in the form of template. So cloud formation, you can create a template, and in that template, you can write instructions like I need a security group. I need an so-and-so EC2 instance with so-and-so public IP address, and I need to have this file to be copied to so and so S3 bucket, and I need a load balancing for this when it is spun up. So such kind of templates, such kind of instructions can be created in a single file. That is nothing but CloudFormation template, and that can be used in your CloudFormation service and can be executed. So once it is executed, it will ensure that all the services are mapped automatically and all the services are enabled according to the instructions what you have given in the template. So that's what like it approach in a declarative way. So having said this cloud formation, so what is the big deal with Ansible or Terraform? So when you're in your company, if you're relatively using AWS, only AWS cloud, in that perspective, cloud formation is the best tool to be used. Why I'm saying? Because you very much know, like probably the people who are from DevOps background and who are actually using AWS, they'll be actually very much knowing that AWS, without knowing or unknowingly, they will be upgrading their AWS cloud, because we'll be not knowing like when the release, what they are actually doing at the back end. So whenever you are actually entering into the AWS screen, today you will be seeing that spot instance is enabled for some of the services. But next day, for example, say for a few weeks after, if you again log in, you will be not seeing that option at all, and you'll be seeing a different GUI. So what I'm actually telling about the updation of AWS services. So whenever the AWS services are updated, obviously the APIs also will be updated. So whenever the APIs are updated, obviously we have to ensure that the Ansible and Terraform, which are actually using that API as a module, to be updated. So that will be taking a longer period of time. So that's where we actually come up with multiple releases. Like 2.9 is the current release of Ansible version, and 0.12 is the current release of Terraform version, wherein they actually deal with the current API service provided by the AWS. So in that case, if I don't need to actually wait for a longer period of time to get that particular Terraform or Ansible tool to be upgraded with the latest API, what actually AWS has. So in that case, I can go ahead with the cloud formation, wherein the cloud formation is inbuilt tool of an AWS, and obviously it will support the upgraded version of AWS services. So now that is the one part. And the second and another part is like cloud formation can update and replace. So whenever, say for example, if you want to create multiple instances using cloud formation, whether it can act as Ansible or Terraform, no. Why? Because cloud formation, it deals with a logical ID. So if that logical ID used for single instance, that logical ID cannot be used for multiple instances. So you can say like, say for example, if any of them are having a hands-on experience in Ansible or Terraform, say they'll be actually coming up with a question like, they'll be coming up with the question like, if I mention Linux, if I mention the count as 2 or count as 1 for a particular instance to be spun up, I can very well spun up based upon the particular instance instructions, right? But the answer is no for cloud formation, because you can't use the parameters as well for mentioning the count as number 2 or number 3, whatever. So similar kind of instructions with respect to a particular instance cannot be brought up using cloud formation. So in simple manner to understand, whenever an instance is brought up in cloud formation with a particular logical ID, that can be done at only for a single instance, not for multiple instance. If you want to have multiple instance, then multiple logical IDs you have to create. Simple as such. But wherein Terraform and Ansible, you can just denote the number with count parameter as 2 or 3. So when you mention the count as 2 or 3, automatically it will ensure that multiple instance with the same configurations is brought up. Simple as such. So now these are the major things which we actually came across, like what is what, what is DevOps, what is DevOps lifecycle is about, and what is a cloud, and how the cloud formation gets into picture, and what how it deals with Terraform or Ansible, and what are the different kind of tools, the emerging tools in the market, Ansible or Terraform or Puppet. So which is the actual best thing? It all depends upon your environment. So it's like uh, Tamil they will say like it's a pantry mandram. So likewise, if you argue like which is the best tool, it's all depend on your environment. So what I can say, if your environment is having AWS exclusively, go ahead with CloudFormation. If your environment is having multiple network switches and multiple VMs, go ahead with Ansible. And then if you want at some point of time, the latest release of Terraform can be used. I mean, if your environment is having AWS, Cloud, OpenStack, and Google Cloud, go with Terraform. And Puppet, if there is no requirement of VM provisioning, there is no requirement of infrastructure as a code, you need to only manage package management as well as the configuration type, go ahead with Puppet. So that's the actual conclusion, what I just want to tell. And now let's get into kind of automation part, wherein I can spun up some instances using Ansible, and instances using Terraform, and instances using CloudFormation. And I will tell you some kind of difference what we discussed about, right? So let's get into the demo
Bala,
part.
there is a quick question, Bala. So can you differentiate on under cloud and over cloud?
Okay, so under cloud, right. So there is a difference of under cloud and over cloud is like the cloud environment which you are actually dealing with is, say, for example, within your your owned data center and owned your, if you're providing your own cloud infrastructure, that actually something comes around under cloud. And the over cloud, in sense, the completely it actually gets into public kind of thing, public cloud. Fine.
No, thanks, Bala. Rakesh, I hope this answers your question. Yeah, you can proceed, Bala. Like we can take up more questions at the end.
Okay. So now let's begin. So if you see, I think my screen share is gone. Let me check. Yeah. So here, this is my Ansible plus Terraform server. So wherein I'm going to actually run some scripts. So this is my cloud environment. So you'll be actually seeing how the instance has been brought up. So now at first, what I'm going to do is like, I'm going to run my Terraform script. So I can't do like this. That's what I was actually going to tell about. So here I have aws.df file, which deals with instance creation of AWS. So to validate like whether my file or whether the code which I have written is correct with syntax or not, I'm just validating with Terraform validate. So yeah, I have the success results, the configuration is valid. So it's valid now. And then Terraform plan. So Terraform plan is something to deal with a kind of a dry run wherein it will tell us like what kind of things will be modified and how the instance will be brought up. So this plus sign ensures that this is an AMI, I mean the image which we are going to use, and this is the instance type we are going to use. Such kind of resources, like what kind of resources will be used to configure a particular instance. So that is what the Terraform plan is about. And how to apply it, Terraform apply. So when I run Terraform apply, it asks for me whether I can go ahead or not. So if I put yes with the same, if you see, come here and watch it out here. So the couple of instance is created, right? So similar way, what I'm going to do is like, I'm going to run up my Ansible script. So to YAML, Ansible, similar kind of thing, like hyphen syntax hyphen check, like validate what we do. Then now I'm going to run EC2 instance. So what happens? It just starts creating one more instance. Hope you're seeing here, one more instance has been created. So, okay. Now, just watch. I'm going to run the Ansible playbook again. Okay. Now watch it here. I'm getting one more instance created, right? Okay. Now, I'm going to run the Terraform script again. I think got delay. Let me log in. I'm going to run the Terraform code again. It refreshes, compares with the state file. So this is the state file which I was telling about. Decide state file, and this is the file which is current state file. So what happened when I try to run the Terraform? It refreshed and it, I mean, the control went to decide state. I mean, the decide state file is Terraform state file, and then it tried to match with the AWS, that is the current state file, and then run the script. What happens is like already the script has been, the script actually been mentioned with 2 instances. Now the 2 sister instances are up and running already. Now again, if I run the Terraform apply command, I am unable to get a couple of instances again running. But wherein, if I use Ansible, each time when I run, an instance is added. Simple as such. So it's a kind of idempotent property wherein Terraform gets into, checks the configuration with decide state file and does all the things. But Ansible, it doesn't do like that. It doesn't compare with any other file. It actually seeks, the control only goes in the particular playbook and runs according to it. Simple as such. So that is a difference. And here, if you want to change, say for example, if I need to change this nano, let me change the instance type to nano. And try to run. Because already my state file would be having, okay, I will show you how the state file looks like. So this is how the exact configuration, how the instance has been brought up, it actually looks like. So here the state file, the decide state file is having micro, but now I am changing the current state file with nano. So let me apply that and see. Okay. It will not apply. If at all I put yes, it will try to modify, but the control will match with the decide state file and it gets failed. If you see, it's trying to still modify. Try to still modify. So if you see here, the instance which has brought up here t2.micro, right? See? So it will not modify. So that's what the major thing. And then one more thing, like if you go ahead with, say for example, cloud formation. So I have uploaded already my file. If I see here, this is my file, EC2 instance file. So I have browsed from my directory and I have uploaded. So you can also view in a designer format, like how it looks like. So next, so I'm just creating a stack name, which is my logical ID name. The next, if you want to add some key values like the tag name mentioning, you can also mention cloud EC2. There are multiple options like rollback policies, stack policies, and other stuff. So I'm just going to mention. And then create a stack. So you'll be seeing all the events, what is actually happening. So regardless of the order which you are actually mentioning in the CloudFormation template, say for example, you need a couple of security group and a couple of public IPs, and then you are actually mentioning the instance type. So whatever maybe the regardless of the ordering, it will actually ensure that it orders like how it is actually needed, and then it actually executes. So that's the major advantage of CloudFormation. So it's getting created. So now if you see here, see it's creating. Is an instance. So if you see the tags, what we have written, Cloud EC2. So in such like such actually in enterprise level, they code and they manage the AWS instances, and it's a kind of a slight difference what we actually discussed. I was actually giving you, providing you here. So that's a part. So as I told you, the conclusion part is like which tool has to be used based upon your environment. So hope you understood like which can be used in your environment. So now question and answers. So before, okay, so you can ask me the questions if you have, and after that you'll be having an interesting quiz based upon our session. So you can take it up, and there will be a comment from our video, like what actually we are actually doing with. So that will be a 5-minute session. So thanks for long
there
wait.
is a quick question.
Yeah.
There's a quick question like, what is fog computing in cloud?
So fog computing is something related to a new emerging technology. So I will check that and I will come across. Okay, I will get in touch with you guys.
Okay, so open for audience questions.
Yeah. So people who are having any doubts?
Sir, good evening, sir. I'm P. Sharad Babu.
Yeah.
Sir, this work environment you are shown, sir, according to the, what are the tools, according to that work environment you are given. But these are all work under any database system, sir?
These actually work under AWS. They will be actually providing a database in the backend. So when on premises, if you are actually asking them, so they will be actually spinning up the instance, and they will be providing the instance for accessing for you. The database and all will be taken care at the backend by AWS itself. So if you are having exclusively database to be created, so there is a service called RDS, wherein you can actually go ahead and use that service and create an relation database in AWS service itself.
Okay, sir, please, can you explain any mechanical systems can we develop like this, sir, in this software, where it will applicable in mechanical systems?
So mechanical systems, yeah. So if you have an AutoCAD software, right? So AutoCAD softwares can be brought up in a kind of instance. So majorly the applications what you are actually using for AutoCAD or any kind of mechanical tools, it would be at the back end, some kind of server will be hosting it, right? Yes, so that server can be actually brought up in AWS, or that can be brought up in any kind of virtual environment in your enterprise, and you can manage of your own with either using an infrastructure as a code tool like Ansible or Terraform. Terraform with respect to AWS, or only Ansible with respect to your particular data center, physical data center.
Okay, so like Similinks, what we followed in MATLAB, like that, Similinks, same work environment is this here?
Yeah, so I'm pretty much unsure about the siblings in MATLAB, but thing is like the tools which are using like MATLAB, yeah, MATLAB and the AutoCAD tool, right? So
Yes,
that
sir.
can be actually brought up under the cloud premises.
Okay, sir. Okay, sir. Thank you, sir.
Yeah, there is a question from Sorupa Rani ma'am. So ma'am, can you raise your mic?
Yes, sir. I am audible.
Yes.
So the question is the for computing and any other tool regarding to the DevOps or especially in research oriented.
Okay, so other tools for DevOps, there are
And the
multiple
research
tools.
oriented point of view, and you can find out the research and the project point of view, the PhD work point of view. At that time, what of the different tools are used on that particular DevOps point of view?
Yeah, so majorly in the enterprise level, the tools which we are discussed here, like Ansible, Terraform,
Puppet.
Puppet. Yeah, so these are the
Okay.
tools actually majorly the people are using since they have been emerging sector with all the modules. But apart from that, there are some tools like SaltStack and Chef, as well as if you go ahead with orchestration tool like Jenkins, and also Circle CI, and then VFS. So many kind of orchestration tools are there, and even Bamboo and Electric Commander. So such kind of things are pretty much costlier. So that's why the enterprise are not going with that, and
Okay.
not going with that support.
Okay. Thank you. Thank you so much, sir.
Yeah. So any other questions, please?
So if there are no questions, I think we can go to.
Sir, one more question, sir.
Yes, please.
Sorry,
Yes,
sir.
yes please.
Sir, for cloud formation is there in cloud formation AWS. How it will be supported for this cloud formation point of view, sir?
Okay, so all the services which are hosted in AWS
Yes, sir.
can be managed using cloud formation service.
Okay. Okay.
So it acts as an infrastructure as code. So
Okay.
it is an inbuilt service which actually AWS offers to you, so that you can manage other services using this cloud formation service.
Okay. And these cloud services should be implemented in real time. For agriculture point of view, you can do any project on this particular cloud formation point of view, sir.
Agriculture perspective, for example, you can create a database kind of thing, like say for example, how many farmers and how many farmlands you are having, and what are the tariffs, and at what date and what time you are actually harvesting, and such kind of database if you are actually collecting, and that database can be brought up under RDS, and that
Okay.
can be actually managed in AWS service.
Okay, sir. Thank you so much, sir.
So great. I think hope the questions are answered.
Thanks, Bola.
So I think please hold for just 5 minutes. So you'll be having some quiz session hosted by our Kiran from the Vigro team. And yeah, so one more thing, like if you want, if you guys are really interested to explore more in DevOps, you can approach Naren from our Vigro team, and he'll be guiding you like what kind of things we are taking up, and you can upskill your knowledge on various technologies, as well as we are in the resource mode kind of thing, as well as we do a product development kind of thing. So multiple things actually we do. So as a team, nothing is impossible. So probably you can approach Naren and you can get to know like what are the details actually what we actually do. And if you want to enroll to upskill your training, upskill your skills, you can get in touch with Naren again and let us know. So thanks all, and probably just spend your 5 minutes time so that you can have your quiz done, and then a wind-up session will be happening. Thanks all. So Kiran, you can host. I think I will stop my screen.
Thank you, Bala. Thank you for a good session. So participants, I have pasted the link to the quiz. So if we can log in there, we can quickly get started, and then we can wind this up in next couple of minutes. So I'm seeing 4 users. So let's wait for another minute, 30 seconds, and see how many people are logging in. Then we can quickly get into the quiz and close this. Five users. You can see 6 users. I have pasted the link in the chat of the Zoom application, so you can just get in there and just log in.
Yeah, I do paste it in WhatsApp as well. Just in case if you're not able to access group chat, I pasted in.
I can see 8 users
in our WhatsApp as well. So you just try to attend this quiz, like to understand the level of knowledge or idea about the cloud formation.
So we have about 8 users. Probably I'll wait for another 30 seconds. 9 users. So we have pasted the link in the chat, so you can just go there, click the chat, click the invite, and you will be able to enter your name and get into this. So now we have 10 users, 11. Okay, I'm going to start the quiz. So there you go. So you will have 20 seconds to answer this question. We have received 2 answers, 5, age. We have 10 people logged in, but we received 8 answers, 9, yes. And the time is up. So 40% gave right answers. So we're going on to the next question. So this is yes or no. 3 answers, age, 9, 10, 12. Okay. 12 people answered this question. So let's see. Yes, 83% got it right. Now Saravanan leads the leaderboard. There is another yes or no question. You have 15 seconds to answer. Already received 12 answers. 13 now. 14. Good. Keep going. The time is up. So let's see. Oh, 50-50. Tough one. The next one. Please go ahead. You have 20 seconds to answer. You have received 7 answers, 13 answers. 14 answers, 15. And the time is up. So let's see how many percentage. Oh, only 33% got it right. We're getting into the last one. Let's see who is going to lead the race. 12 people answered, 13. Last few seconds. Last few seconds. And time is up. And the answer is, okay, only 20% got it right. The leaderboard. Congrats, Saravanan. Good show. So that brings the end of this quiz. Over to you, Naren. Thank you.
Yeah, thanks everyone. There is a technical glitch all over the world. You can see the message like Zoom is having issues for the past few hours. So that's one of the reason we are unable to join and start the session on time. So anyway, thanks for your patience and thanks for participating our session. So if you have any questions, we can connect offline. And if you want to know anything from Bala, please reach me. I will help you to connect with Bala. You can have a detailed one-to-one discussion with him. Okay. So thanks for your time. Thanks for joining. Have a great day. Thank you.